Hi there, welcome back. Welcome to video 3 on the repair-restoration of this Grundig Satellit 3400. If you are very observant, you'll notice it's back in the case. So obviously I'm doing this introduction at the end of this stage because when I left off last, I was going to start the recapping and checking of that power board. Well, I've got news for you. It's now working and yeah, well, thanks for watching. Bye for now and stay safe. You want to see some more? Stick around. It's actually quite interesting. The saga continues. I have recapped this whole board. All the electrolytics and the tantalums have all been replaced. Very good quality components in here. So I have no doubt that this thing has been done properly. And then, of course, I tried it. Put it on battery. I've got a signal going in here in the appropriate connector for external input. I've selected that at the top and let's switch it on. This power is still a bit iffy. Okay, it's there. Watch this. You can hardly hear it. Now if I tap this here, I was doing it just now. Anyway, the point is I've got a 1 kilohertz signal coming in here and it's hardly coming through. I think there are cold solder joints on here. I want to show you the back of the board and you'll understand why I think there are cold solder joints. This is what the back of the board looks like. It really is a bit messy. I think maybe someone has been in here. I noticed some of these connections have been resoldered. Some of the wires seem to have been resoldered. So what I'm going to do is I'm going to clean up this whole back of the board, touch up any solder joints, check to see whether the tracks are all intact. There's a few suspicious ones here. See these tracks here? Sometimes they corrode right through. So I have to check that. Of course, I could do that with checking the voltages first. But before doing that, I think I'm going to do the cleanup and a physical check first, because I think it'll be more productive at this stage. All right, folks, much time later, you can see there's quite a difference here. The boards were cleaned. I used a brush, one of these sort of natural bristles. They're quite rough. And I use that with isopropyl alcohol, rub everything down. I put something under here, some tissue paper or something, because it all just runs down and all the grime and crap just accumulates on there. So brush it down, wash it off, and the board is clean. And then what I did was I checked some of the solder joints. These boards, there are two daughter boards on here. One is on the side going up and the other one is on there going up. Those daughter boards are soldered on the insides, and because they move a bit, I was worried about some cracked joints, broken solder joints, so I retouched up all those joints. I checked some of the connections here. Some of the wiring was soldered pretty badly on here. That's why I believe somebody was in here at one point. I checked these tracks over here. They're all fine. They're all, well, they look a little bit corroded, but they're making contact. Some of the tinning has come off, but they're okay. And I think this thing is ready for some testing. Now, obviously, the first thing I want to do is check voltages and bias and things like that. I think what I'll do is I'm going to start with the service manual, see what they ask us to do, and see if this thing behaves itself. Remember the service manual? If we carry on down here, they give us alignment instructions, and the first one here is adjusting the operating point. That is the operating point of the output stage. I'm quite keen to find out if that's working. So I'm going to do this first. What do they tell us to do? They say no signal, okay. V supply is 9 volts, so I'll set up 9 volts on the power supply and supply that to the battery connections. Medium wave depressed. And with control R636, adjust the quiescent current of the output stage, which is transistor 606 and 607, to 6 milliamps. Instead of the bridge, connect milliamp meter to collector of. Okay, during this adjustment, the loudspeaker connection must be terminated with 4 ohms and the volume control must be turned fully anti-clockwise. Okay, no problem. Put the volume on 0. Adjust the emitter current. Oh no, this is a different thing. This is already on the other board. And the BFO board. Okay, so I'm only interested in this point number 1. Let me set that up and see what we get. We need 6 milliamps plus minus 1 milliamp. I'm actually quite curious to see what it's giving at the moment, if anything. Well, it's providing something because we're getting some audio, but I don't know whether it's balanced or not. I must admit, this took me a while to find. In there, that's the transistor. From the collector, there was a solder bridge. There was a blob there. I couldn't actually see the break in the PCB on the track, but I finally found it. I removed the break. I soldered a little wire to the collector side, and I've got this. I've got the multimeter, the ammeter, positive on there. This is ground. This is the other side. So the negative's connected on there. I have the speaker connected, so this thing's properly terminated. Volume set fully anti-clockwise, so on 0. No input. I have the power supply coming in there to the positive of the battery connection and the ground. The power supply is set to 9 volts. I've put a 100 milliamp limit on there just in case. I'm going to activate medium wave as requested. Now the trimmer I'm supposed to adjust is the one in there. It's a little trimmer down there. You can hardly see it, but it's there. It's behind this middle transistor. So we should be about ready to go. Okay, let's switch it on. Now I want 6 plus minus 1 milliamp. Okay, it's not too bad. 5.4, let me see if I can adjust it. If I can adjust it, it means that that part of the circuit at least is working okay. Yeah, it's adjusting. Takes a little while to settle down, that's normal. Well, that was easy. Yeah, we've set it. 6 milliamps plus minus 1 milliamp. We can actually get it to pretty exactly or pretty close to 6. So our bias is done. It means that the output stage is working fine. Good news. All right. I was actually expecting a lot more than this. Switch it off and on. Boom. Goes up to 6. It's stable. Good. That's one more task done. Well, what we've done is we've just aligned no signal, medium wave depressed. We've aligned 1. With control 636, adjust the quiescent current to 6 milliamp plus minus 1 milliamp. That's perfect. And the volume was turned anti-clockwise. So that one is done. These two are adjustments that need to be made on other boards. So I'm not going to do that. I want to finish this board so I can get it back. What else do we have on this board? We have the charging voltage. Okay, here's another one we can do. With the main supply of 240 volts AC and the receiver switched off, adjust R658, which is a 1K trimmer, so that the charging voltage VC into an equivalent resistance of 1K and electrolytic of 1000 microfarad is 9.1 plus minus 50 millivolts. Okay, the power supply unit should be on for approximately 2 minutes prior to this adjustment being carried out. Yeah, the power supply is never really off because even if the radio is off, it's supplying voltage to the charger. All right, let me see where that is and set that up as well. Let me show you what we've got here. As instructed, I've got the main supply in here. I've also connected a capacitor, a 1000 microfarad capacitor with a 1 kilo ohm resistor. So this becomes a capacitor slash resistor load. That is connected to where the battery will be, the ground to the ground, and the positive is connected to the yellow wire, which is the charging connector. I've then got the multimeter across here reading volts. The radio is off, but it has been connected to mains for a little while. And look what we got. Not bad. 9.43. It's supposed to be, what is it supposed to be? 9.1? 9.1 plus minus 50 millivolts. And the actual adjustment is this guy over here. It's a little trim pot, and the way to get it or get to it is from this side. There's a little hole on that daughter board. This comes through and you can then adjust it. Yep, it's in there now. Let's see what we need to adjust, or how much we need to adjust. So what do they say? 9.1. Oh. There we go. Now that is pretty close. I'll leave it for a while, make sure that it stabilizes, and I think we've done it. Just a note, when I finished that idle current adjustment on the other side, I had to remake that solder bridge. And you know what? The only time you can't get 2 points to bridge with solder is when you want to. I had to put a little wire just between the 2 points to make sure the solder filled the gap. But that's done now. All right, this thing is very stable. That tells us a few things. It tells us that the driving circuit of the output transistors seems to be fine. No guarantees yet, but at least as far as DC is concerned, as far as the power supply is concerned, it seems to be fine. It also tells us that the charging circuit, which is a part of this board, seems to be fine as well. I don't think I'm ever going to charge a battery on there, but at least it's working and we know we can adjust it. So now what I need to do is, I think I'm going to need to just do an audio test on this board by supplying a signal to the phono or the external input over there and looking at it on the scope. I think that's what I'll set up for next. What I'll also be doing is probably building a dummy load, or I have built one, but using a dummy load. This is 2 8 ohm resistors in parallel. It's actually 8.2. So the 2 in parallel come to 4.1. I've got one of those DIN connectors. This is perfect for that output over there. So I'll be able to just plug this in and monitor the output across here, so we don't have to hear the noise. You know, when we pass a signal through it, I want to see how far this amp goes up and so on and so forth, because I really do want to put this back into the chassis, into the case. Power supply set to 9 volts, 100 milliamp current limit, and we'll activate it. Supply is connected to the battery connections. Signal generator is producing a 1 kilohertz sine wave at 100 millivolts. Activate it. Signal is plugged into the external source. This particular wire here is ground, and that one is 3 and 5, so playback mode. Our external source is selected here. I have a DIN plug plugged into the external speaker socket there. That speaker then comes to the speaker input here on the dummy load switcher. It's on speaker at the moment. I can put it on dummy if I want. We'll leave it on speaker so we can hear it at first. And I've got 4 ohms selected for the dummy when we select that. And I've got channel 2 of the scope monitoring that speaker or dummy, whatever is activated at the time. And now all we need to do is switch it on. and give it some volume. And we can hear it. Okay, we can hear it, and it's quite clear. I'm going to switch to dummy load now, so we can still see it. Let's see how far this goes. Drop the scope range. And the power supply has exceeded the limit, the current limit, so I'm going to increase the current limit to 200 milliamps. And that's as high as it goes. Volume is on full. And I'm reading 740 millivolts on the scope. Now what I'm going to do is I'm going to increase the signal generator level. Let's drop that first. 200 millivolts RMS coming in, and take that up, still going. Drop the scope range. Oh, that's hit a maximum as well, and the 200 milliamp limit on the power supply is already being exceeded. I'll put that at 300 now, but we've hit a maximum. Let me go down in amplitude, increase that to, let's put it at 400. Whoops. 400. We can always control the volume here. So it's on 400 millivolts coming in, 9 volts supply, and this is going up. 300 milliamp limit on the supply, which I've just reached. 2.28 volts RMS output. There, it's hit the current limit on the supply. I'm going to increase that to, I'm putting it up to 500 milliamps. Drop the range of the scope. And we've now got, still going up, we've hit a limit, and this limit has got nothing to do with the current range. It's peaking, it's clipping. There's the limit of clipping. This has got to do with the actual supply voltage, which is only 9 volts. So with 9 volts, I'm getting, before clipping, which is about there, 2.7 volts RMS output into a 4 ohm load. Okay, what do we do next? Well, I want to see where this goes. So I'm going to increase the voltage supply to, well, I'm going to put it up at maximum 16 volts, which is what they tell us is supposed to be the maximum on that external supply. It says on the back there, it says 10 to 16 volts. So 16 volts, and I now can go up. Well, that's as high as it goes with a 400 millivolt input range. That's, what's that? 3 volts, just under 3 volts. Let me increase that to 500, 600. Whoa. Okay. It's tripping on the current. So I'm going to increase the current to 600 milliamps. Let's see where that goes. Change the range. Okay, that's 600 milliamps. It's drawing 580. I'm putting it up to 700 milliamps, and I'm going to give the input supply another 100 millivolts. Okay, now I know that it's clipping because it's clipping, because that's really the limit. 16 volts supply, it's drawing 570 milliamps. 700 millivolts is the input range. And I'm getting 4.43 volts RMS out. And this thing is pretty clean. I'm not sure what this thing's supposed to produce, but 5 watts on that size speaker is a good amplitude. It's a good level. So it looks like it's all working. Or is it? Well, I've got it on FM. I've got the volume on max. And I can just about hear it. This here is supposed to be a very strong station, and I'm getting very, very little. This is in one of the strongest stations I get here, 89.3. And look at that. That's not working. Doesn't seem to be working at all. And the volume is abysmal. Maximum volume. And the tuning, it's not that far off. In fact, it's quite close. There's another one on 88. I get it. It's very weak. I mean, this one I should be getting very, very well. And this is across the entire band. I'm actually picking up stations from, this is weird, man. This thing is from North Africa. At 104.8, I'm getting something which is either Canary Islands or North Africa. So it's picking up pretty far, but the level is atrocious. The only thing that could really affect it is the AFC. What else would it be? This is not active. The tone is affected. That is the light. There's nothing else that could really affect this, except that the signal coming from the FM section is very weak. Now, when I go to AM, we'll see what happens. We'll try medium wave. I forgot to select external antenna. So that's reading correctly. Reception. That's about normal for this time of day. Now, friend warned me about this switch. This is the bandwidth switch. Let's go down to this set in the middle. Let's go down to wide. This is definitely not right. Yeah, I guess it's definitely louder there. So something is affecting the volume level. That's not completely kosher. What else could affect this? That's noise cancelling. Bit of hum comes through there. So that's not very good. Let's try shortwave 3, which is the drum over here. Now, as we can see there, it's supposed to be on shortwave 4. Where would we get something at this time of day? Probably around here. I'll put it on the band, the full band. Sorry. This is still very low, and this is jumping around, but that's got to do with the switch on the side here. I know that. So I'm going to have to clean up all the contacts there, but that isn't what worries me. What worries me is that the general audio level is very low, is relatively low. It's better on AM than on FM, but it's generally low. Now, I've got the 2100 to compare to, and just a note on the power rating of this thing. I've got it connected to mains at the moment, and it says that the maximum power is 5.5 watts, which is pretty loud. And we seem to be getting that with the external input. If you remember, I think I measured about 4.9 watts before clipping. If I went into clipping, it would go on to probably 5.5, 6 watts. So it seems to be okay. However, there's one thing I don't know. To get that 4.9 watts on the output, I had to put the input signal, the input level, and I think it was about 600 millivolts RMS. Now that's supposed to be line level input, which would be fine for about 600 millivolts RMS. So I think that the gain of this power stage is fine. You see, my concern is, what if there's a stage here on the preamp section that's not amplifying enough? What if I'm getting 4.9 watts simply because I'm shooting up the level, the amplitude of the input signal? I mean, if you've got a problem of gain, if one stage is not giving you gain, but it's still letting the signal through cleanly, then you might be thinking that it's working fine because you just keep upping the input level and it's giving you the output. But I think the input level to get full output is about right, which means that the audio coming from this AM section to the switch that selects between radio and phono or external input, that audio level getting there is low. That's what I think it is. And I'm getting it on the FM as well, which makes it even more weird. Because if it was just AM, yeah, you could understand it, but it's AM and FM. What I might have here is two separate problems. I might have the AM not working well because the level is low. It might have something to do with some of these switching levels here, like noise reduction or the width of the band or something like that. So that might be giving me a problem. And I might have an actual problem on the FM which has got nothing to do with the AM problem. Because usually when you've got the same problem with two sections, you immediately say, right, it's the common denominator. What is the common denominator? As far as I can establish, the common denominators here are power supply and the audio amp, preamp and amp. Once it goes into the preamp or into the audio path, they should all be treated the same, wherever the audio comes from. There might be something I don't know about this yet. There might be another common denominator, a common stage that affects both the AM and FM. And I have to do some research on this. I have to study the schematics. This thing is also not operating well. Could this be a different problem? I don't know. Could these actually be a lot less sensitive than they're supposed to be? I don't know. I'm just thinking out loud. There is something. This is a common denominator between the FM and the AM, which means that the detection circuit might be pulling everything down. I don't know. If you have any ideas, I really would appreciate it. I mean, Stefan mentioned that he had a problem with the switch. This is the bandwidth switch. He said, if your AM is low, check the bandwidth switch, because he had a problem. He actually had to desolder the whole thing, dismantle it and clean it up because the spray cleaning didn't do a good job. And the reason is people put this in one position and leave it for life. And if it doesn't go the other way, these contacts tarnish. So the switch probably wasn't used and it could cause a problem. That would explain the AM, but it doesn't explain the FM. So a lot of you have got experiences that I haven't had on these sets. If you do, give me some hints. I could use them. Derek, another viewer and friend, said that he had a problem with the FM where one of the IF transformers had a problem with the internal capacitor. I'll have to check that as well. So, hey, help me out here. If you have any ideas, let me know. And for now, I definitely will be signing off now. So I want to thank you for watching. I want to thank you for your support. The comments have been great. People seem to love these sets. I love it. So keep them coming. There is no such thing as a stupid comment. There might be a stupid answer from me, but that's a different story. So yeah. Anyway, once again, thanks for watching. Bye for now. Stay safe.